Welcome. Today we will start new chapter, that is root locus method. Locus means graph. Root means these are the roots of the characteristic equation. Therefore, in this chapter we have to draw graphs of the roots. Therefore, how to draw the graph of that roots? Different roots are there, real and imaginary. Therefore, how to draw that graph, we will study that. First of all, we will study theory based on the root locus method, and then one by one we will see the problems. Syllabus: significance of root locus, angle and magnitude conditions, breakaway points, angles of departure and arrival, construction of root locus using general rules and steps, and after that we will see problems. Now, first point, significance of root locus. The stability of any closed loop system depends on the locations of the roots of the characteristic equation, that is, the locations of closed loop poles. The nature of the transient response is closely related to the location of the poles in the S-plane. It is advantageous to know how the closed loop poles move in the S-plane if some parameters of the system are varied. Such movement of the poles can be known by root locus method, introduced by W. R. Evans in 1948. This is a graphical method in which movement of poles in the S-plane is sketched when a particular parameter of system is varied from 0 to infinity. In root locus method, gain is assumed to a parameter which is to be varied from 0 to infinity. In general, the characteristic equation of a closed loop system is given by 1 plus GSHS is equal to 0. This is the closed loop control system. RS is the input. This is the summing point. This is the negative feedback. Again it is fed to this K element. Again G dash of S. Again C of S is nothing but control output. This is the takeoff point. That is feedback signal is taken. This is the feedback element. Again it is fed back to this summing point. For root locus, the gain K is assumed to be a variable parameter and is part of forward path of closed loop system. This is known as forward path. This is known as reverse path. Means when you will move from left to right, it is known as forward path. When you will move from right to left, it is known as reverse or backward path. Consider the system shown in adjacent figure. Here GS is equal to, or G of S is equal to K into G dash of S, where K is equal to gain of the amplifier in forward path or also system gain. The characteristic equation becomes 1 plus GSHS is equal to 0, that is 1 plus K into G dash of S into H of S is equal to 0, which contains k as a variable parameter. If now gain k is varied from minus infinity to plus infinity, then for each separate value of k we get separate set of locations of the roots of the characteristic equation. If all such locations are joined, the resulting locus is called root locus. So, root locus is defined as the locus of the closed loop poles obtained when system gain k varied from minus infinity to plus infinity. When k is varied from 0 to plus infinity, the plot is called as direct root locus, while when k is varied from minus infinity to 0, the plot obtained is called as inverse root locus. But generally the term root locus is used in the sense of direct root locus. Unless otherwise stated, the variation in gain k is assumed to be 0 to plus infinity and plot is called root locus. For example, consider unity feedback system with g of s is equal to k divided by s. Obtain its root locus. Now we will solve this equation g of s is equal to k by s. The characteristic equation for closed loop system is, this is our characteristic equation in general, 1 plus g of s into h of s is equal to 0. But for unity feedback system, h of s is equal to 1. If feedback is equal to 1, then h of s is equal to 1 and g of s is equal to k by s given data. Therefore, substitute this value in this characteristic equation, 1 plus gs hs is equal to 0. Therefore, 1 plus k by s is equal to 0. Therefore, s plus k is equal to 0. Therefore, the root of this equation is located at s is equal to minus k. Now, if gain k is varied from 0 to plus infinity, the location of this root is going to be changed. So, the locus obtained by joining all such locations when k is varied from 0 to plus infinity is root locus as shown in figure below. Therefore, this is the diagram. On y-axis is known as imaginary axis, always remember in case of root locus. X-axis is known as real axis. Now these are the values of k. We have varied it from 0 to infinity, that is 0, 1, 2, 10 up to plus infinity. The s is equal to minus k, root location. Now when substitute value of k here, therefore s values you are getting it at 0, minus 1, minus 2, minus 10 up to dot 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 up to minus infinity. Therefore this is nothing but from this 0 coordinate to this left hand side of x-axis up to s is equal to minus infinity. This is nothing but root locus of that equation. Now next point is angle condition and magnitude condition. For a general closed loop system, the characteristic equation is 1 plus GSHS is equal to 0. Now this equation we will see throughout this chapter. Now therefore GS into HS is equal to minus 1. As S plane is complex, we can write above equation as GSHS is equal to minus 1 plus J0. All S values can be expressed as sigma plus j omega, that is g of s into h of s term is also complex one. So for any value of s, if it has to be on the root locus, it must satisfy the above equation. As both sides of above equation are in rectangular form, we can convert both sides in polar form and then we can equate angle and magnitude of both sides. Now In that, first point is 8.2.1, that is angle condition. The characteristic equation as mentioned above is g of s into h of s is equal to -1 plus j0, equating angles of both sides. Therefore we have to equate angles. Therefore angle of g of s into h of s is equal to plus minus 2q plus 1 into 180 degree, where q is equal to 0, 1, 2, 3 dot dot dot. Now -1 plus j0 is equal to 1 into angle of plus minus 180 degree, but the point -1 plus j0 is a point on the negative real axis which can be traced as magnitude 1 at an angle of plus minus 180 degree, comma plus minus 540 degree, plus minus 900 degree dot dot dot, plus minus 2q plus 1 into 180 degree. Therefore angle condition can be stated as angle of g of s into h of s for any value of s which is the root of equation 1 plus ghhs is equal to 0 is equal to plus minus into bracket 2q plus 1 into 180 degree, where q is equal to 0, 1, 2, which is equal to odd multiple of 180 degree, because here plus 1 is there. That's why if you will put any value of q here, it will become odd multiple of 180 degree. Now magnitude condition. If magnitudes of both sides of the equation g of s into h of s is equal to -1 are equated, then we get a magnitude condition, that is mod of g of s into h of s is equal to mod of -1 plus j0 is equal to 1. Now in the function g of s into h of s, k is unknown and hence we cannot find out mod of g of s into h of s at any point in S plane. So this condition is not suitable to check the existence of a point on the root locus. But once we know that a point in the S plane is on the root locus, then it must satisfy magnitude condition also. So at that point which is known to be on the root locus by angle condition, we can find out value of k by using magnitude condition. This k is value of gain for which a known point on root locus is the root of quadratic equation. So magnitude condition states that mod of g of s into h of s at a point in S plane which is on root locus is equal to 1. So magnitude condition can be used only when a point in S plane is confirmed for its existence on the root locus by use of angle condition. Now next point is breakaway points. These are all the points that angle condition, magnitude condition, breakaway point, these we have to find out by using some equation. These equations are there. While solving problems you will understand. Now breakaway points. Breakaway points, name itself indicates break. Break means what? In Marathi it is called tutne, or it is leaving. Therefore when at the point at which the root locus leaves the x-axis or real axis is known as breakaway point. Therefore it is a point on a root locus where multiple roots of characteristic equation occurs for a particular value of k. The root locus branches always leave breakaway points at an angle of plus minus 180 degree divided by n, where n is equal to number of branches approaching at breakaway point. As breakaway point indicates values of multiple root, it is always on the root locus. Now next point is angle of arrival and angle of departure. Angle of arrival and angle of departure are discussed below. As branch always leaves from an open loop hole, it is advantageous to know at which angle it departs from complex conjugate pole. This angle at which it departs from complex conjugate pole is called angle of departure, denoted as phi d, and vice versa. It is an angle of arrival denoted by phi a. Therefore, phi d is equal to 180 degree minus phi, where phi is equal to summation of phi p minus summation of phi z, where summation of phi p is equal to contributions by the angles made by remaining open loop poles at the pole at which phi d is to be calculated. Summation of phi z is equal to contributions by the angles made by the open loop zeros at the pole at which phi d is to be calculated. Therefore, these are the some points. In next lecture, we will discuss what are the different steps to draw the root locus. We will stop here. Thank you very much.